Hello and welcome to the first video on tree diagrams. This video is just going to be kind of like a go-to video that explains the notation at every single level of the tree. Okay, depending on how many levels of events or different categories of each event, okay, it could create different possibilities at each level. So let's get started. Let's just start off with a very basic example. So I'm going to say we have an event A. Okay, that's the first event. And we have an event B. Okay, so one has to come first. So A is going to be first. That's going to happen first. And then B is going to happen second. So I'm going to do a couple of variations of this. Okay, so event A. This is the event that A happens, so there's two choices here, because either A could happen or A may not happen. Okay? Same thing with B. This is B happening. The complement would be B not happening. Okay? So this is where A happens, this is where A doesn't happen, that's where B happens, this is where B doesn't happen. Okay, so the way we start off the tree, okay, is I only have two different categories here, two different possibilities. Okay, A could have that tree goes up and then comes there. Okay, so here's the start of my tree. This right here, I don't do this normally, but this right here is designated for the first event. That's where most of the mistakes happen. People want to put A on here and B on here, but that's not the case. This is the first event. Okay? So the probability of A would go on this branch, and the probability of A complement would go on this branch. Okay? So this is, if A happens, you go this way. If A doesn't happen, you go this way. Okay, so now I'll pick a different color. And now we're going to need two branches off here. Okay, so let's go two branches off here. Okay, there's, and two branches here. There's my two branches. So the second possibilities, these second branches, is the second event. The second event happening. So what's that? That would be our B event. This is our A, and this is our B. Okay. So there's going to be a probability on both of these branches, just like there's a probability on these two branches. Now we know that the sum of this one, the sum of this plus this has to equal 1. So let's talk about B. Okay. So this is going to be the probability that B happens. Okay, but you're starting here. This is where you start. You have a choice. Either this happened or this happened. Okay, so if you're dealing with these, then the top branch happened. So A happened. So this is the probability that B happens given that A was the initial happening. Okay, so make sure you understand that. This branch right here, the second branch, is the probability that B happens given A happened. Okay, so this one here, if B happens, there's another possibility too, and that's this one here. If this is that B happens, and this is the probability that B doesn't happen given. Okay, so who happened all in this top branch? A happened. So this probability right here is the probability that B doesn't happen given A happened. Okay, so now if I'm on the bottom branch, A didn't happen. So this branch here is the probability that B happens given A didn't happen. Both of these will be that. This is the probability that B doesn't happen given A didn't happen. Okay? So it sounds confusing, but watch it over again. It makes sense. Now remember, the probability of A plus the probability of A complement equals 1, because these are the only two possibilities. Remember, the probability of the sample space, and in this case the probability of these two. So if A was 80%, then the probability doesn't happen is 20%. Same thing here. These two add up to be 1. I don't want to confuse you with formulas, but this one plus this one equals 1. Same thing with this one. This one plus this one equals 1. This one plus this one equals 1. That one plus that one equals 1. That's important. Okay, now let's get into some more notation. And generally when we do, we don't know if these are independent or not. It still has to be tested. But say I want the probability that A happens and B happens. Okay? So we know this formula. We're not sure if it's independent. So if you're not sure if it's independent, okay, you have to use the formula. But look, the probability of A and B happening. All I'm doing is taking this path right here. I take this path. I go here, and I go here, and I multiply them. So the probability of A and B is the probability that A happens times the probability that B happens given A happened. And remember, that's just my formula. Okay? So what happens if I ask, what's the probability that A happens and B doesn't happen? Okay, look at that path. If A happens, I'm going to start here. Okay, I'm going to start here. Start going this way. But B doesn't happen. So I don't go here because this is B happens. B doesn't happen, so that's down here. So I do this number and I come follow this path. Okay, let me do it in. I do it in highlight. Okay, so that would be that route. And you always multiply through your branches when it's ands. You always multiply through your branches when it's ands. Always remember that. This is the probability. You can't see that too well. This is the probability that A happens times the probability that B doesn't happen given A happened. Now remember, these are going to be all numbers. These are going to be numbers between 0 and 1. This is the probability, so it's going to be between 0 and 1. So you're just multiplying some decimal times some decimal. Okay? Now, down here, it could be what's the probability that A doesn't happen and B happens. So what pathway is that? Look at the pathway. A doesn't happen. So if you're starting here, A happens up here, A doesn't happen down here. So I'm going to follow this path. A doesn't happen. Now I'm here. Now B happens. So you have a choice. You either go up or down. If B happens, that's the top. So I follow that path and you multiply. So this is the probability. That's the probability that A doesn't happen times the probability that B happens given A didn't happen. Okay? You watch this video enough, you'll start to get what I'm talking about. You'll get real good at this notation. Okay? So the last case would be, what's the probability that A doesn't happen and B doesn't happen? Okay? A doesn't happen and B doesn't happen. So let me change colors a little bit. So A doesn't happen. That's the first event. A doesn't happen. So I'm starting. A doesn't happen is down here. Now I get here. Now what's my second event? B doesn't happen either. So I keep going down because A doesn't happen and B doesn't happen. So that's going to be the probability. That's going to be the probability that A doesn't happen times the probability that B doesn't happen given A didn't happen. Okay, and most of the time this is given, they have to give you, this has to be given, or this has to be given. You notice I have or, because if they give you one, you know the other one. Or this has to be given, or this has to be given. Okay? And put an and here. Because they have to give you one of these, and one of these up here. That's the only way to do this. Because you know this plus this equals 1, so if you know 1, you know the other one. This plus this equals 1, so if you know 1, you know the other one. This plus this equals 1, so if you know 1, you know the other one. Okay? So now, the only problem with this is it's a little harder to see, conditional probability. Well, these are your conditional probabilities right here. But what happens if I just say, but before I go into that, there's something that I have to note. Okay? That's very important that you have to see. Okay? So this, I draw an arrow. Let me change the color. This is an outcome. Okay? That's an outcome. That's one possible outcome. It's this. So that plus this is a different outcome. The final answer. That plus this plus this plus this equals 1. These are four different possibilities, and they're the only possibilities that could happen. Okay? Either A and B is going to happen, A is going to happen, B is not going to happen, A is not going to happen, and B is going to happen, or A is not going to happen, and B is not going to happen. So that's very, very important to know. Okay? So now the question is, what if I just turn around and say, what's the probability that B happens? Now it's a little confusing. So pay attention to what I'm saying. The probability that B happens. Okay? So the probability that B happens is 2 of these. It's 2 of these 4 possibilities. And all these possibilities are disjoint because this can't happen the same time as this. And this can't happen the same time as this. They're different possibilities. That's why they all add up to be 4. So the probability B happens, there's 2 ways to do this. So look at this, look at these 4 and which one have B in it. A happens and B happens, or A doesn't happen and B happens. There's 2 ways B's could happen. There's 2 ways you could get B. There's this way, and there is this way. So if they just ask for the probability of B, it's 2 of your final outcomes. So I don't want to confuse you too much with formulas, but it's the probability that A happens and B happens, plus the probability that A doesn't happen and B happens. Okay? These two, you just add these up, and that equals this. Okay? Because this is going to come in handy because if I asked you a conditional distribution, if I asked you a conditional probability, for example, I say, what's the probability that B given A happens? Okay? So with this is we just have to look at our tree and just find it. Oh, that's right here. Okay? Where they say, what's the probability that A doesn't happen? We just look at our tree. Probability A doesn't happen, that's just right here. Okay, what's the probability of B? What's the probability B doesn't happen? That's a little more difficult. The probability B doesn't happen, okay, it could happen 2 different ways. It could happen here. It could happen this route. I shouldn't say there. It could happen that route. Or it could happen that route. So you have to multiply these, and then add them together. Okay, so I'll just write the formula for this. Probability that A happens times the probability that B doesn't happen given A happens. It's probably plus the probability that A doesn't happen times the probability that B doesn't happen given A didn't happen. Okay, but now I'm going to switch it up and make it a little more difficult. And this is the only tough part. And this is called Bayes' theorem. And really, I shouldn't really be showing you these formulas. I mean, it's kind of cool to know if you want to be a little advanced, but what's the and I'm going to switch these probabilities around. Now I'm going to say, what's the probability A happens given B happens? Okay, so let's see if we could, now we have to kind of use the formula. Okay, and it's a little tricky, and I don't think they've really ever asked this. So if you want to stop listening now, you could stop listening. And if you want to keep on listening, because it is actually kind of, it's pretty fun. So if you remember the formula, we didn't really do the formula too much, but this is the probability of A and B happening, okay, divided by the probability that B happens. Okay, so this is the thing. What's the probability that B happens? I just did that. I did that right here. So that would be this probability. B happens. So that would be this probability. Okay, and here's the B right here, and the probability that this happens. So you take these two and add them together, and they go in your denominator. Okay, so that's this right here. So I'm just going to take this and put an arrow. That goes in the denominator. Now what's the probability that A and B happens? Okay, so think about it. This is going to be larger, right? Because this is this outcome plus this outcome. I have two outcomes. Well, the numerator is one of these outcomes. Look, see, that's probability of A and B. That's which one? That's this outcome right here. So it's actually pretty cool. Okay, because if you switch the conditions around, okay, and make it a little more difficult, two of the outcomes get added to the bottom, and the top is just this outcome. I'll draw an arrow. Okay, that's called Bayes' theorem. It's a very important theorem if you go if you get into higher statistics, and it's really interesting, and there's a lot of history behind it. But so that's it. So I'm going to actually show a couple examples using this, and you'll see that it's really not that difficult. And some students prefer this, and they always use tree diagrams. Okay, because you don't necessarily have to use the contingency table. Some students like tree diagrams so much they use it. Okay, you have to know the tree diagram though, because sometimes they'll put a tree on there, and they'll start asking you. They'll start asking you these ands. Okay, so remember, ands get multiplied through the tree, through the branches. Okay, conditionals are on the branches. Okay, make sure you know that. So thanks for watching. That's it.